And now our next speaker, Anthony Shaw, is getting ready to impress us with his stories about what's new in Python 3.11, right? Hi, Anthony.
Yes, that's right.
Hi,
Hello,
Anthony.
how are you?
How are you doing?
Hey, how are you both? Yeah, I'm good. It's
just a moment, we couldn't hear you.
Can you say it one more time?
Yep, can you hear me? How about now?
Alrighty.
Okay,
and
we still talking. Just a moment.
Yeah,
Justin is on our side. Okay, so Anthony.
Yeah, how now?
Oh,
Yeah,
nice,
you're with
nice,
us.
finally.
Nice.
Okay. Okay, cool.
Awesome.
All right, hello.
How's your mood?
Hi. Yeah, good. I'm good. I'm in Australia and it's nighttime here, so other side of the world.
Wow, it is early in the morning for us. The
Yeah, good
MultiConf
morning.
is indeed all over the world.
That's right. Did you have a Red Bull or some green tea?
No, but I've been playing soccer all afternoon, so I'm quite wide awake. Yeah.
Quite
Okay.
jazzed.
So energized, good.
Awesome.
Yeah, energy is good. Exercise is good.
Awesome.
Yeah.
So a word to you, Anthony. You are welcome to start with your presentation and lecture and have fun.
Okay, great. Thank you very much. And hello, everybody. Welcome to MultiConf. That's a really tough act to follow from Gil. That's a brilliant presentation. Some interesting perspectives. So I'm going to talk to you today about Python 3.11, which is a new release. But before we do that, first of all, hello, I'm Anthony. And this is my website. It's tonybaloney.github.io. I've got a blog on there. And links to a lot of the stuff that I'm doing. You can also follow me on Twitter at Anthony PJ Shaw. I've also written a book on the Python compiler, and if you want to get a copy of this, let me know. There's a paperback version and a ebook as well, and that covers a lot of the stuff that I talk about in my talks and my presentations. So before we get started, I just want to say it's a real privilege to be able to speak to everybody today at this conference. We originally started talking about MultiConf in January, I think it was, when it was still being discussed as an in-person conference, and I'd love to be there in person. It feels like we are a very long way away over here in Australia, but you know, I really have so much sympathy and concern for everybody over there in Ukraine and everything that's been happening. So really, my heart goes out to all of you. And yeah, it's just a pleasure to be here and a pleasure to speak to you today. But we're going to talk about Python. So that's a bit of a difference. So if you're looking at this and thinking, okay, 3.11, where did that come from? So we're here at the moment. So Beta 1 is the current beta version of 3.11. The actual release comes out in October, November time this year. So I'm going to talk to you about what's new in 3.11 and then what's coming in 3.12, 3.13, and in future versions of Python as well. So at the moment, a new version of Python comes out once a year. It used to be every year and a half, but that changed about 2 years ago. So some of you maybe are running on 3.10 if you're running on the bleeding edge, and most people are running on 3.8 and 3.9. So I've written a quick summary of all the Python 3 releases to try and summarize you know, what you may have missed if you're just coming into Python and this space recently. So 3.0 to 3.3, don't use any of those. They were all very buggy alpha releases of Python. Even 3.4 was really still a beta release of Python 3. So don't use 3.0 to 3.4, so they don't really count as Python 3 releases. 3.5 was really the first stable release we had of Python. And then I've kind of grouped them into three different sections. So 3.5 to 3.7 is where we got asynchronous support, so the async and await operators in Python. This is where that got introduced, and over those three releases, it got matured as well. 3.6 is where we got the f strings feature, the format strings, which I know a lot of people really like. And then we also got type annotations, which is a theme that comes up in this talk as well, of things which are coming in the newer versions of Python. So type annotations were introduced in 3.6 and then have been improved from 3.6 all the way up to 3.10. And they're still making adjustments to type annotations and the typing system in general. And this is really improving, I think, the quality of a lot of the Python code, being able to annotate the types. And then to summarize, I guess, where we're going from 3.9 to 3.12, the focus is on performance. So I've given a talk, a couple of talks in the past at PyCon in the US on Python performance and why I think Python is slower than other languages, including Node.js, and how that potentially could be faster in the future. And the exciting news is that there's a team of people working on this now. So there's a team of people working on making Python faster, and we're going to start to see some of those changes coming out in 3.10, 3.11, and 3.12, and I'll talk about that as well. So if you haven't got up to speed with Python 3.10, you've missed a really cool new feature called the match statement. And here's a little example of that here. So in the match statement, we can do matching of dictionaries, matching of sequences like lists or tuples. You can also do matching of literals. So in this example, I'm matching a sequence and I'm going to look for emojis in here. So I'm going to look for a sequence that starts with a frog and ends with a butterfly and a flower. And then if that happens in the list, then I'm going to return that string. And then if it starts with a frog or ends with a butterfly, ends with a butterfly, and then so on. So the match statement looks like a switch statement that you might see in C type languages, but it's actually not a switch statement. It's a pattern matching statement that is carried across from functional programming languages, which is why you can use this special pattern matching algorithm in the case statement itself. So it's not as literal as a switch statement as you might see in C and C++. This is actually used for matching. It's great for matching sequences like lists and matching dictionaries. If you're interested in this, I've got a article on my blog about a whole bunch of examples you can use. So that was really the big new feature in Python 3.10. Okay, so if you want to get started with Python 3.11, depending on where you're installing it, there's a couple of recommendations for you. So if you're on either Mac OS or Linux, then I recommend you get a copy from python.org and go to the downloads page, and then you'll see a little link that says pre-releases. If you click on that link, you'll get a list of the 3.11 release. Like I said earlier, beta 1 is the current version, but beta 2 comes out, I think, next week. So yeah, make sure you kind of keep up to date. I don't recommend that you download and install from source unless you know how to configure link time compiling and profile guided optimization, which are both quite complicated. So yeah, I'd say use the release builds on the python.org website because they've been optimized already. And then if you're a Windows user, you can use the Windows Store, or you can use python.org. But if you use the Windows Store, Python 3.11 is on there, and it will update to the newer versions automatically as they come out. So beta 1 is already on the Windows Store to download for free. Cool. Okay, so one of the changes coming in Python 3.11 is that exception messages are changing. And I've got a little before and after example here. So at the top, I've got a bit of code, and you can see I'm doing a print statement, and that it's giving me an index error saying the list index is out of range. But I've actually done two. It could either be data 0 or it could be the number 2. So it's not clear which one it is that's causing the error. So in 3.11, you'll now get this sort of squiggly line underneath the error message with some arrows pointing to which part of the statement actually caused the exception. So it's a small feature, but it's a nice one. I think once you've used it a few times, you get used to it, and it really adds a lot of usability. It's not yet supported in IPython, but it will be probably by the time 3.11 has been shipped. Cool. Okay. A new feature is a new type of exception that's coming called an exception group. And to explain this one, I've written a small example program that's going to process some orders of food. So if you see lines 7 to 11, I've got some orders here. So eggs and spam, ham, spinach, ricotta salad, cola, and rice. Cola and rice would be a pretty interesting option for lunch, but you know, that's what I could think of. And for each one of those, I'm going to try and process the order in a try except statement, which is going to call the function at the top. And then if there's more than 2 items, it's going to raise a value error. If there's less than 2, it's going to raise a value error. So that's great. But normally, the first time it raises an exception, the whole program stops. But I actually want to process all orders in the list. And then if there are errors in those orders, I want to see all of the errors, not just the first one. So what you can do in 3.11 is you can basically add a note to an exception using the add note method on an exception type. And then you can raise a new type of exception called an exception group. Exception group takes a name and then a collection of exceptions. So normally a list or a tuple. Exception groups are handy in this kind of example. They're also being used in the standard library for some of the networking APIs where you might get multiple errors from a single call, and you can actually ask to see all of the errors, not just the first one. So that's a new type called exception group. And to accompany that new type, there are a couple of extra features. So the first one is that if your code throws an exception group, then in the command line, you'll see this new view. So here I've actually got both orders that raised an error. So I've got value error, not enough items, and then just the one that says ham. And then underneath, I've got too many items in order, spinach, ricotta, and salad. So instead of just printing a stack trace with the first error or the exception group, on the command line, it will now by default print out all the exceptions in the exception group. These are called sub-exceptions. And so, yeah, like I said, it's a useful feature. Now, you can also do something else to handle sub-exceptions or exception groups, and that is to extract exceptions from groups. This is a new piece of syntax, and I've highlighted it here. So I've just extended that example I showed you before, where we're going to try and process orders in a list and then raise an exception group. And at the bottom, I've got a new try except block. And after the except keyword, I've got a star and then value error. Except star is the new piece of syntax. And this basically says, if there is an exception group, then extract all value errors out of that exception group and then give them to me as the variable, in this case, VE. So this is a list of exceptions. And then you can handle each one of those individually. So in this case, I'm just going to take each of those exceptions in the group and then print any notes that might be attached to it. You can also use this for async IO task groups, which is a new feature that I'll talk about in a second. Okay, so if you've ever used async and await or async IO in Python, there is an API for running multiple tasks in a collection called gather, which is great, but there's a few steps to set it up. Async IO task group is a new type that's been added to the async IO library, and you can see it here. So here I've got just an example application where I'm going to connect to multiple servers. I haven't actually implemented the connect method because it's not important to the example. What is important is that we can have an async with block on line 9, and we're going to use a task group. So this is the new feature, is the task group. And then with that variable TG, we can create a task and then give it a coroutine to basically add to the task group. The task group will then run all the tasks in that group within the with block. And then once they've all completed, then the with statement finishes. Now, if any of them raise an exception, they will get added to an exception group. So similar to what I showed you before, where you can have an exception group that has multiple exceptions. If any of those tasks raise an exception, they will be added to the exception group. So that basically means that you can have a try statement and then an except star, and then extract any exceptions out of each of those tasks individually. rather than having a group and then only seeing the first exception that gets raised. Okay, there's also a number of changes to typing in Python 3.11. The first one is the introduction of a self type. There is, of all the typing stuff that I'm going to show you, there is a backwards compatibility package on PyPI if you want to add these to Python 3.9 or 3.10, but they will come out of the box in 3.11. So in this example, I've got two classes, one called person and one called admin person. And in person, I've got a class method from DB that will take a key, like the person's identifier or something, and then instantiate the class from the database. I haven't actually implemented it. I'm just trying to show you how the typing annotation would work. Now, previously, if you said that from DB returned an instance of person, then any classes which inherit from that type will still think that from DB would return a person instance. So if you've got an admin person underneath, then you would expect that from DB would return an admin person. This is quite hard to do in typing. So what they've added instead is a new type called self. And that basically means that it refers to the class in which that method is defined. So we've got here the person and the admin person classes. And then I've got two pieces of code, one where I'm going to create an instance of person from the database called me. And then underneath, I'm going to have one called super me. And if you look at how VS Code will see this, it will say, okay, from DB will return an instance of admin person because it knows that it returns of type self. And I'm calling that on admin person. So it knows that it returns the correct type. It's great for factory methods. And if you have a lot of inheritance in your code and you are using typing, this is also a great feature. So you'll see if you go a bit further as well, then if you add any kind of methods and stuff that you have on the classes which inherit from the base type, they will be correctly annotated in VS Code and in PyCharm. And also if you're using any type linters or something like MyPy, for example, it will correctly know that those methods exist on the subclass rather than the base class. Okay, another feature which has got a complicated name is Variadic Generics. So to explain this one, I've tried to put together an example that kind of makes sense and then show you what it looks like in the IDE. Now, whether or not you'll actually use this feature is a different debate because not everybody uses a lot of typing. And then if you do use typing, whether or not you use generics is another topic entirely. So the concept with the generic is that you have a type variable and you define a type variable at the top of the module. And then you refer to that type variable in either the definition of the class, like I've done here on line 6, or you refer to it in the methods. So type variables are useful when a class or a method can do multiple things, and you want to refer to the type that it could be used for in different ways. So here I've got a concept of a packet, like a network packet, and it is a generic that has a type that the packet would be represented by, which I'll use bytes, and then it would have a number of fields. So if you do network programming, maybe you might have a length field and a body field, which might be a string. So T fields here is a star because it's a tuple of types. So this type packet can basically be reused for multiple types. So here I've got on line 18, you can define a packet and say that the T packet is bytes, and then T fields is an int and a string. So expect to have two fields, an int and a string. Now that means that my typing system knows that the constructor for packet should receive an integer and a string. So on line 18, I've said packet 56 and a string. So that's all been determined just because I've put the annotation here on line 18. And then on line 19, that same annotation knows that the fields property defined in the class, shown on line 11, returns a tuple of T fields. So it will basically unpack those fields into the typing system. So it knows that when I ask for the fields of the packet, it will return an integer and a string in a tuple. And that's what you'll see on line 19. And then finally, you can return, just as you can with generics already today, you can annotate the data property on line 15 to say that this will return whatever T packet is, which was defined back on line 18. So this is quite a complicated way of using typing. But so if you're using typing in complicated code like this and you're using generics, this is going to be a really useful feature. But the way most people will see this feature is that libraries that they will use, the typing is basically being improved. So yeah, if you're, like I say, if you're a library maintainer, this is great news for you. If you're a consumer of libraries, I think you'll just get a general improvement in your development experience. So on the theme of typing, there's another feature called a data class transform. So this basically allows you to implement your own versions of the data class module that comes in Python already, and then get native support for type checkers and IDEs. This has already been implemented in libraries such as Pydantic, if you use Pydantic already, and it's also been implemented in some ORMs and ODMs, like the Django ORM. So they already have this behavior. Here, I'm implementing it across David Beasley's minimal data class with a K library. Data class, the rewrite of data class that Dave Beasley did is trying to be as small as possible so that it's more performant. The data classes that you get in Python today are great. They have a lot of features, but they are really slow. They're basically about half as, well, they're twice as slow as a normal class. So if you use data classes to instantiate them, to run the constructor, or to get any of the magic methods, they're about basically twice as slow as a normal class. And I've got lots of information on that in at the end of the talk. So in this example, all I've done is use Dave Beasley's data class, and then you'll see that I've defined a new class called car, and I've given it some fields, make, model, engine capacity, and turbo. And then in VS Code and also in PyCharm, it will now know that this is a data class, and therefore the constructor should have all of those fields set automatically. So you can see that when I try and instantiate that car class, it pops up with all of the fields that it's expecting. And it'll also correctly annotate all of the fields, such as the engine capacity. It will know that that is a floating point. Yeah, an Audi RS4 definitely doesn't have a 1.2 liter engine for any car fanatics out there. So that's my first mistake of the presentation, but never mind. Okay, we have a new library in the standard library as well. So TOML is, I think it stands for Tom's Obvious Markup Language. It's a very minimal markup language. It's designed as an alternative to YAML. And it's basically just a lot simpler. It has fewer features, but if you need a really simple configuration file, like an INI file, then it has most of the functionality that you would need. And this has only really been available in Python if you download a package from PyPI, which is a bit strange because the new way of defining packages in Python is to use a pyproject.toml file instead of a setup.py file. So Python packaging is moving towards having a TOML file for the configuration, but until 3.11, there was actually no way of reading the TOML files without installing a third-party package. So they've added a standard package to the standard library. It can only read TOML files. It can't write TOML files. So if you've used the JSON library or the PyYAML library, you'd expect both a load and a dump method to both read and write from the file. TOMLlib only does load. So as expected that the writing of the TOML file is done by a human, and not a script. So you can use it to read from any TOML file. It's also got a quirk, which I noted that you have to use binary mode when you're reading the files. Something I fell over the first time I tried it. Okay, so now to, I guess, some of the juicy bits. So I mentioned earlier on, I've done some presentations on Python being slow. I've got a talk from PyCon, I'm trying to remember which year it was now, 2020. Why is Python slow? And in that talk, I talk about a few benchmarks in particular that show where Python can be a lot slower than other languages, not just compiled strongly typed languages like C++ or C# or Rust, but it can also be a lot slower than other dynamically typed languages like JavaScript. So comparing JavaScript and Python is probably a better comparison when you look at performance, because in terms of the languages, they're both very dynamic. So performance in Python has never been a top priority, I'd say, until fairly recently. It's more been about the, I guess, the usability of the language and its application in different environments. So there's a few ways that people have come up with to get around this performance problem in Python. I guess the most extreme way of getting around this is to write things in a sublanguage called Cython. Cython is a transpiler that will basically turn your Python code into C code and then compile that C code using the GCC, the normal C compiler, and then make it available to you as a module that you can load. So Cython is used by a lot of libraries that you would probably use today, a lot of scientific libraries, NumPy, a lot of NumPy is written in Cython. A lot of the scientific libraries that are written in Cython, and some other things like encryption libraries are also written in Cython. The reason is because if you can rewrite something in Cython, you can make it up to 100 times faster, which is pretty significant. However, you've basically, instead of writing Python, you've got to write it in this kind of pseudo Python C language, and you've also got to be very specific about the types. So if your code requires that level of performance, often Cython can be an option, but the level of changes you need to make is pretty drastic. Another option you've got is just to throw more hardware at the problem. So this, I guess, doesn't require any code changes, which is great, but it requires that you have a very big expense budget, which is normally a problem for people. And there's basically some middle ground solutions. One of those is a project called PyPy, Pypy, which is an alternative Python interpreter written in Python. And this basically allows you to just write normal Python code, and then instead of running it in CPython, the Python that you're probably running today, you can run it in PyPy. And PyPy can be anywhere from 2 to 20 times faster, depending on the code and depending on what your code is doing. In some cases, PyPy is slower, so you have to be really careful with your benchmarking to check whether you've measured it beforehand. And also, it doesn't have a lot of compatibility with C extensions. So that's often why people can't use PyPy. Also, most of the time when your application is running slowly, it's not actually Python that's the issue. It's the database or the disk or the network or whatever IO bottlenecks you have in your app. So yes, you should always optimize those. And then often adding caching tiers into your application will make it faster. These aren't Python specific, but you should always consider this as well. And then lastly, the one I want to talk about is minor version Python upgrades. So this is where upgrading to version of Python can make a difference in how fast it runs. And then I've got one more, which is to optimize your existing code, which I recommend you doing. And if you're interested, I'm working on a linter at the moment called perflint, Perflint. And I can provide a link to that as well. Perfluent is the linter that will basically give you optimization suggestions in your Python code. And I spoke about that at PyCon 2022 in the US only 3 weeks ago. But we won't cover that now. I'll just talk about the minor version Python upgrades. So before you get stuck in with looking at performance, you need to know whether or not the newer version of Python has made a difference. And to do that, you really need to use some sort of profiler to measure your code's performance today. And there's lots of profilers to choose from. There's one built into Python called cProfile, which is fine. Like it kind of does the job a lot of the time. It will tell you how long your code took to run. But if you need more information than that, or you want async IO support, or your program uses multiple processes in the multiprocessing module, or uses threading as well, then you might want to look at a different type of profiler. So the ones I've highlighted at the top are Austin and Scalene. These are brilliant profilers if you're looking at optimizing parts of your code, so actually line by line. They require a bit more to set up than some of the other options, but they give you a lot of information. So if you were looking at Python 3.11 or 3.10 anyway, and you want to measure whether it's made a difference, I also strongly suggest that you run both of these profilers, because when I've run them on my own code and other people's code, it often tells me things like this. So this is Scalene, and it's running on a bit of Python code. And what Scalene will do is when it gives you a result report, it will tell you which lines of code are costing the most amount of CPU time. So if your code is running slowly, which specific lines of code or which functions are causing the most amount of CPU time, and also which ones are causing the most amount of memory usage. So this is great if you want to do some real analytics of your Python code. Scalene does this, and also Austin, which is the other one I mentioned, does this. Austin's also got a VS Code extension. So instead of printing it out on the command line, it'll actually highlight the lines in VS Code that are causing basically the most amount of CPU slowdown. Okay, so one of the big features coming out in 3.11 is specializing adaptive interpreter, which sounds really complicated. So the specializing adaptive interpreter basically means that in some parts of Python, it's very dynamic. So, if you're multiplying two numbers together, the number of things that it has to do to run that multiplication is massive, because it doesn't know that they're both numbers. It doesn't know that you've created your own special number type. Like, there's so many things that you can do in Python. You can override the built-ins. You can pretty much monkey patch absolutely anything in Python. So Python itself, it's quite hard to optimize because it is very dynamic. So a new feature of Python 3.11 is this, basically some changes to Python itself that will build in some shortcuts. And this is part of a project to basically make Python 4 to 5 times faster over the next few releases. So over the next 3 years now, we're going to see big step changes in Python's performance. There's also a range of other small updates in 3.11. Some important ones is that exception blocks no longer have an overhead. I don't know if anybody knew this watching, but basically when you have a try except statement, that actually adds quite a significant overhead in the CPU and also in the size of the stack. Regular expressions are now a little bit faster, and function calls also have a smaller overhead. So all this is interesting, but what does this actually look like in real terms? So I've picked up 2 benchmarks that I ran on my machine last night. 2 benchmarks that are in the PyPerformance benchmark suite. There's about 30 or 40 benchmarks in that suite, I think. But there's a few that I think are really important if you want to look at real Python code and not just like benchmark code. Benchmark code is kind of a bit funny. It's like, okay, calculate pi to 500 digits. And it's like, when would I ever need to use that? So these are quite realistic benchmarks. They're also reproducible ones. So they should give you the same result each time. Delta Blue and Richards are the benchmarks that I pulled out. And I've compared here Python 3.9 on the left, Python 3.10 in the middle, and Python 3.11 on the right-hand side. And each of those graphs shows the execution time of the benchmark. So on the left, you'll see Delta Blue. This is a benchmark that has a lot of classes, method calls, class methods, and lots of loops. If that sounds like your code, then you might see this kind of improvement between 3.9, 3.10, and 3.11. So about 20% performance improvement going from 3.9 to 3.10, and then a further 50% going from 3.10 to 3.11, which is massive. So it's basically twice as fast to run the benchmark between 3.10 and 3.11. And then on the Richards benchmark, not as drastic, but still pretty decent, about 30% drop from 3.9 to 3.10, and then a further 20% from 3.10 to 3.11. So this is good news if your code uses a lot of classes, inheritance, and method calls. For example, if you're using a web framework, this is probably the case. So if you're using Django or Flask, then even if your code doesn't look like this, the code that you're using does. So you won't see such a drastic drop as this, because most of your execution time in your web apps will actually be talking to databases and the network weighting and stuff that's not in your control. But for the stuff that you do control, such as processing data and analyzing requests and stuff like that, that should be a lot faster. If you're doing scientific Python or mathematical Python, the n-body algorithm is one that plots the orbits of planets, but it's a good benchmark to analyze how good Python is at running loops and how good it is at doing floating point arithmetic. The n-body algorithm is actually a weak point of Python compared to JavaScript. I think Python runs this particular algorithm about 100, I think it's 50 times slower than JavaScript, which is mind-boggling. But this is it's a good step in the right direction. So we're looking at about a 60% performance improvement between 3.9 and 3.11 here again. So this is a massive drop, and 3.12 should improve on this even further. Okay, and then the other benchmark I wanted to bring up was serializing and deserializing JSON. This is something that people do a lot. And I also wanted to highlight that not all the benchmarks are as promising. So serializing JSON isn't actually that much faster in 3.11 than it was in 3.10, and deserializing it is slightly faster. I think that's probably about 10% difference, but like it's not a huge difference. So not all Python code will be significantly faster, but all of it will be faster. So I think when they've promoted the performance gains, they've talked about a 20 to 25% difference. However, like I've shown you in this benchmark, it could be up to a 60% difference, which is about 2.5 times performance gain. So what does that mean for you? I'd expect somewhere between 20 and 30% improvement in most applications. But you're not going to know any of this unless you benchmark your code beforehand. If you're concerned about performance, then you should be doing this anyway, because there are probably bits of your code which are causing it to slow down that you could fix already today. And if you're already on, if you're on 3.9, then you're going to see a huge difference in speed going from 3.9 to 3.11. And this benchmarking is showing that you could actually get twice 2x performance difference, which is massive. And yeah, we should expect even more in future versions of Python as well. So yeah, what can we expect in the future? So 3.11 is coming out in October. 3.12 is already being worked on. And in 3.12, there's a couple of features that they're working on. One is lazy imports, which you'd be surprised how many import statements there are in Python code. And when you import one library, how many other things that it imports. And often it will import things, but they're not actually used. So lazy imports is basically a way of optimizing that to make it more efficient, both in memory usage and in CPU time, so that when you import a library, it can be a lot quicker. and it will only pull in imports when it needs to. Also working on a per interpreter GIL. The GIL is a part of Python that basically locks the interpreter so that it can only work on one thread at a time. This means in effect that if you write multi-threaded code that is CPU bound, then you don't basically see a sort of parallel scaling when you do multi-threading if it's a CPU type operation. Now, one of the engineers on CPython is working on a solution to this. It was called the subinterpreters module, and it's now being called the per interpreter GIL. Still a work in progress. You can run this today in 3.9 and 3.10, but it's still pretty beta quality, I guess. But 3.12 should have a more stable API for that. And then Python 3.13, 3.14, and 3.15 are also scheduled. And there are some features being discussed, but most of them are scheduled for 3.12. At the moment, there isn't anything significant put in either of those releases. I know for sure that there will be a 3.14 release, because that is the first 3 digits of pi, and they want to make that the pi release. And as of yet, there is no Python 4 or a mention of Python 4 or a discussion about Python 4. So yeah, if you're curious about when they'll stop adding numbers to the end of 3 and turn it into 4, I don't know, to be honest. And there's not going to be a big transition like there was between Python 2 and Python 3. They've said multiple times they're not going to do that again. So if there is a Python 4 in the future, it might have some breaking changes, but not the same size and scale of breaking changes that Python 3 did versus Python 2. Cool. So in summary then, I say that you should start testing soon so you're ready to upgrade. You can already download Python 3.11, like I mentioned before. You can get this from python.org. You can also run Python 3.11 on CI if you're running GitHub Actions or Circle CI or one of the other CI providers. You can get that already. You have to put in GitHub Actions, you have to do Python 3.11-dev, DEV, and then it will know to use the latest beta version. I strongly recommend that you benchmark your code so that when you've done the upgrade, you can test what the performance difference is. And this is also a great thing to go and tell your boss that, you know, this is why we should do an upgrade, because it's going to make all our apps 20% faster, 50% faster, who knows, like it could be something significant. Faster code means less, less waiting, but also it often means less hardware as well. So in a lot of cases, that's great that it speeds up, but it means you can actually provision less hardware to run it. So it should be cheaper as well. And then if you haven't already, look at the concept of gradual typing. So if I've gone through the typing stuff today and you thought, you know, typing sounds great, but I just haven't got around to it, I haven't managed to explore, and adding types to all of my code would just be so time consuming, and you just get yourself in a mess when you try and do that. It's really hard to annotate code that has never had any types. There's a concept called gradual typing, which is kind of self-explanatory, but you add types slowly and gradually to your code. And then kind of as you kind of progress, you might find that you actually have to refactor your code to add typing. So, you know, you've got a function and it could return a tuple, a list, a string, none, or a class. And trying to describe that in typing is reasonably straightforward, but you know, you end up with this massive annotation that says this function could return all of these things. But gradual typing is good because you can actually look at that as a developer and say, maybe my function shouldn't return one of 5 different types in the first place. And how can I refactor that to make it a bit more sensible in terms of what it returns back to the developer? So yeah, that's everything I wanted to go through, and I've got plenty of time for questions.
Yes, thank you for your speech, Anthony. There seems there's a lot of new things in Python 3.11, and there looks like there's more to go and lots of plans for the future. So I suppose long live Python, right?
Definitely.
Alrighty, so should we start with the Q&A block?
Yep.
Awesome.
So you should
Sure.
have questions running on your phone, I suppose, right now.
Yeah, okay, I can go through these. Okay, so what features of the new version come in handy more often than others? Well, I'd say performance is probably going to be the big one. That's going to be super useful to have a performance difference. Other than that, if you're using a lot of async and await, then async task groups is going to be a really good feature, because the way that you have to do, if you've tried to use the current system, it's just a lot of code and it's quite confusing. And then the way that you handle exceptions and stuff is a bit messy. And also I showed like the arrows underneath the errors and how they give you more information. I think for beginners, that's like super helpful. So most of the stuff I showed is like for intermediate and advanced developers, but the friendlier error messages are good for everybody. I think that's a pretty cross-cutting feature. Are there any features in Python that you're still looking forward to? Yes, definitely. I'm looking forward to using sub-interpreters, which I refer to as a per-interpreter GIL. So Eric Snow is the engineer that's working on that one, and I tested it, a very early version of it in 3.9, and I do cover it in my book as well. I think that can be, once it's been developed and it's been completed properly, I think that could be a great way to have like properly parallel Python code running with small overhead. So, you know, my machine here has got like 4 cores and it's probably hyper-threaded as well. So you could easily run, you know, like 40 different threads. If you're running stuff on a GPU as well, you know, you've got sometimes hundreds of cores. So, you know, you want to have stuff that can run in parallel. So combining both the asynchronous APIs and the parallelization APIs, such a hard word to say, will be a big advantage. How difficult is it for a beginner to transition to using Python? Okay, so I mentioned Python as a way that you can make your code faster. How easy is it for a beginner to learn how to do that? Okay, so there are actually 2 options when you write Python code. You can write the special Python syntax, or you can just use type annotations. This is a new feature, and I'd say go down that path. So use normal type annotations and then try and adopt Python that way rather than using the special Python syntax. I'd say it's more logical and you get a lot more support in your IDE and stuff like that. That is reasonably easy to learn. But I think the promise of Python is that you get this like massive performance improvement. In reality, you only get a performance improvement when you make your types concrete. So if you say this variable is definitely an integer, this variable is definitely a float, like once you do that, then you get the performance improvement. If you just throw your current Python code at Python, it will probably be about the same. It might be a little bit faster, but it's not going to be massively faster. Python's great once you've done typing. If your code uses a lot of classes and inheritance and things like multiple inheritance, Python often isn't the right solution because it's not great at that. It's really good for scientific stuff and code where you've got a lot of math. How do you see the future of Python? In what direction will it be developed? Okay, so 3 weeks ago at PyCon US, a project by Anaconda was announced called PyScript. And this is showing Python in the browser. So it's just instead of a script tag like you'd have in HTML, it's a PyScript tag. And then you have to have one JavaScript file that you download and put on the page. And you can just write Python and you can your Python runs in the browser, and it can interact with all the HTML on the page. You can draw graphs, you can do all sorts of cool stuff. So PyScript, I think, is a step forward and showing where Python is going. Excuse me. And that is into new platforms. So Python at the moment is used for data science primarily. So it's running in Jupyter notebooks. So it's running in, all this backend code, or it's being used in web apps. So those are the two main use cases for Python: is web apps and a lot of backend code, or data science. And Python has never really kind of taken off on the desktop, so in like the user interfaces and in the client space, and it hasn't really taken off in the web space either on the client side. So the project that Anaconda announced a couple of weeks ago, PyScript, which is backed by something called Pyodide, basically compiles Python down into WebAssembly, and then it can run natively inside the browser, which is fantastic. It's pretty early days. It's super beta. There's still lots of issues with it, but I think that is where Python is going, is to kind of be more accessible as a web client, web language, which opens it up to things like phones and tablets and devices and stuff like that, where JavaScript dominates, because it's pretty much the only language that you can run inside basically is the only language you can run in the browser. So if you're writing anything client-side web, then you have to use JavaScript, and there hasn't really been a choice. But I think the way that WebAssembly is going, then there will basically open up the possibility of writing other languages in the browser, like Python. What development tools do you prefer? On my blog, I've got a page dedicated to how my environment is configured. It's a bit complicated, which is why I had to write a whole blog post about it. But that's because of what I do as a job, and I, run so many different versions of Python. I use VS Code as my development environment of choice. I work for Microsoft, so that's but I was using it before. And I've got a lot of customizations to VS Code. So it's not just standard out of the box VS Code. I've got about 100 extensions to VS Code now, I think. And I'm running on a Mac. I also have a Windows machine here that I use for testing and builds. You should always use a virtual environment. That was part of the question. And I'd also recommend checking out the remote extensions in VS Code, because if you're developing on a Mac but you're deploying onto a Linux server, chances are you are using some sort of container like Docker. And basically what this extension allows you to do is to use VS Code natively, but the actual code runs inside the Docker image. So debugging works, all the integration features and stuff like that work as well natively. So that's something else I'd recommend. What pitfalls may arise when switching to 3.11? Okay, so this question is, I guess, about, what should you just go and upgrade now, and then what could go wrong? At the moment it's beta, so there could be bugs. There are also things which have been deprecated. So there are APIs which have been removed in 3.11. There's a list of those on the release notes. You should have had warnings in 3.9 and 3.10 if they were going to be removed in 3.11. However, most people don't have warnings enabled. So the problem with deprecation warnings is that most people have them switched off, so they don't actually see them in the first place. So there's a possibility that some of your code could stop working because APIs have been deprecated, which is why you should start testing it soon. Other than that, I think you'd be pretty good to go, to be honest. Like everything you've got, unless it's been deprecated, then it should just exist the same way it is today. Do you think there'll be a Python 5 someday, and what functionality will it have? This is an interesting question. So I think the version scheme of Python is funny because they're kind of stuck on Python 3 now. So it will be Python 5? Probably, yes. What features would I like it to have? I would love a couple of things. I'd love Python to be as fast as JavaScript as a benchmark, so that people don't keep asking me why Python is slow. But in most cases, it's not slow. It's just if you're involved in this optimization arena. And the other thing I would love is for Python to be just native in the web. So, from any week to week, I'm writing JavaScript or TypeScript and Python. And when I write a web application, I'm writing Python in the back end and JavaScript in the front end. And if I'm writing like React or something like that, then I'm writing like this weird spaghetti React syntax and then some TypeScript. And it's really hard for me to switch between 3 different languages. I don't know how people do it, to be honest. I start putting curly brackets in my Python code, and I start thinking that white space is significant in my JavaScript, and it all just becomes a bit of a mess. So what I'd love to see in the future is that I can just use Python across the board, and that is seamless, and it just works, and it's quick. And I think we're starting to see sort of like a move towards that. But I'm teaching Python to people in school. I'm teaching Python to my kids. But when you show them what Python can do, a lot of the time you're showing them a command line application, which to my 10-year-old kids is like really boring. They're like, why do I care about this? Because on their phone, they've got all these apps that are like, all these really cool graphics and stuff. And they're all written in Java or Swift or JavaScript. And they're written in languages which have got all that tooling and all that history. But Python as a language is really easy to learn, and that's one of the great features of it. But how you actually apply that and use it is still quite limited. And I still think you're quite limited to kind of like scripts and backend code and data science, which is awesome. If you're a scientist, it's brilliant. But for people who are trying to get into programming and wanting to do stuff that's visual and they can see it and they can interact with it, I think it's a bit limiting still, but it's changing. So yeah, and if I could have anything, it would probably be that. I think that's all of the questions.
Okay.
Alrighty then. Thank you very much, Anthony, for your lecture, for all the Q&A. I can see that you are very passionate about what you are doing, what you are sharing, and I think the number of questions proves it for sure. So thank you very much for being with us. I hope you had a pleasure as well, and we for sure invite you for the next conference as well.
Yeah, I'd love to come in the future. I've been to Budapest before. It's a beautiful place.
It is. Indeed.
But yeah, I'd love to go to Kharkiv or to Kiev.
Yeah, the next one will be in Kharkiv, so book the tickets.
It will be a pleasure to meet you there.
Yeah.
Awesome.
Definitely.
So thank you very much. You have a great rest of the day, and if you're interested, please connect and look at other lectures that we have. We are also counting down how many viewers did we have at each day, so stay tuned.
Or have a good sleep.
All right.
That's also an option.
For sure. You will find out in the morning.
All right.
Awesome.
Thank you, everybody.
Thank you.
Thank you.
Bye.
Bye.
Bye.